All right, so today we're going to talk about the chain rule, which is the big rule for taking derivatives. It comes in every single time, and so you've got to make sure, no matter what, that you're paying attention to see um, if the chain rule applies and how you have to use it for each particular problem. Um, Basically, the chain rule says this: that if I have a function that is made up of another function that has a different function on the inside. So this may seem strange, but um, it really isn't. You could think of lots of different things. So basically, any function that has a function inside of it. So a lot of times you'll see things like maybe the sine of 3x. Well, that's just 3x inside of sine. So that is a composite function. Um, and that would very much apply to this. Even really just sine of x is also a composite function. You've got a function x inside of a function sine. Many other examples. Anytime you could have any sort of function, so 3x plus 3. If we were to take that to the fourth power, this is now a function inside of another. So there's lots of examples of this, and you'll see it come up all the time. But the chain rule is a very important concept to understand. It says that the derivative of this function, what it is going to be, is it's going to be the derivative of our outer function. But we still keep our inner function intact. Now, this is an important part. Then we multiply by the derivative of our inner function. So we don't account for this inner function, really, its effect on everything, until the end, where we tack on the derivative. So it's a very outside looking in scenario. So just as an example, if I had something like the sine of 3x, like I showed you before, okay, we have an outside function, which is the sine, and we have an inside function, the outside function, which is sine, and you have an inside function, which is 3x. So what you have to do is the derivative of sine, if this is f of x, then f prime, derivative of that is going to be, it's the cosine. Derivative of sine is cosine, but I need to keep the 3x. Then I multiply by the derivative of 3x, which is 3. So you end up with 3 cosine of 3x. So that would be just an example of how that looks and how that works, is that you respect the whole function over time, but you do it in pieces. Now there's also a general power rule for how derivatives work, and that would be like this. If you had a function that was some value to the nth power, then its derivative would be defined like this. N times u to the n minus 1, so just like the power rule, but at the end you multiply by the derivative of u. Now, with the regular power rule, you're still doing this, you're just considering one thing, and that's the derivative of x is 0. So if we did this old method, we said x to the 6th power, this is the same thing as 6 times x to the 6 minus 1 times the derivative of x, which just ended up being 6x to the 5th times 1, right? We never really considered that we had to do this because the derivative of x is just 1, so we would leave it out. But it's still there, So a new example of this would be if let's say I had 2x to the 6th. Now you could expand this out, but we could use our new general power rule to do this. So this is going to be 6 times, remember we leave the inside alone, to the 6 minus 1. Multiply this by the derivative of 2x, which is 2. So this is 6 times 2x to the 5th times 2, which is the same as 12 times 2x to the 5th. So quite a different looking problem, but it works out about the same. The thing is, you always multiply by the derivative of the innermost function, which for the older versions that we've been doing has always been 1, but the newer versions will be very, very different things.